I will be discussing the problem statement merge two sorted lists. The problem statement says you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists and then return the head of the merged linked list. The problem is a fundamental problem, and the approach that we are going to take while solving this problem is, as the list is sorted, we start at the beginning of both the lists. We can just compare the values, and if one list is empty and there are still more elements that need to be traversed in the second list, we can just take those elements and insert it in the output. The solution code creates a dummy node to act as a starting anchor and a tail pointer that will build the merge list. Then then we loop while both lists still have nodes. At every step, we compare the current values of both the lists. Whichever node has the smaller value gets attached to tail.next, and we move to that list's pointer forward. Then we move tail forward to continue building the list. Once one of the lists become empty, the other list is already sorted. So we simply attach to the remaining nodes directly to the merged list. Finally, we return dummy.next because dummy was only a placeholder, and a true merged list starts from its next node. The time complexity of this solution is big of n plus n, and space complexity is big of 1. The patterns which are observed while solving this problem statement were, again, two pointers pattern, where based on the intuition of this problem statement, there are some different points that exist in the two pointers pattern for this type of problem. First is maintain two moving pointers L1 L2, compare current elements and advance one pointer at a time, appears in arrays, linked list, strings, intervals. If two things are sorted, think two pointers. Second is dummy node sentinel pattern. Use a fake head to simplify edge cases. Avoid special handling for the first node. Extremely common in linked list construction problems. Dummy nodes removed conditional chaos. Third, in place modification pattern. Reuse existing nodes instead of creating new ones. Tests pointer discipline and memory efficiency, common in linked lists, trees, and graph rewiring problems. Rewire, don't recreate. Fourth is incremental construction pattern. Build the answer step by step. Each iteration adds exactly one correct piece. Used in merges, traversals, and greedy algorithms. Build correctness locally. Globally ordered images. Sixth is tail pointer pattern, where we keep a pointer to the last element of a growing structure. Avoid repeated traversal at the end. Used in queues, linked list, BFS levels. Never search for the end if we can track it. Seventh is exhaust and attach pattern. The intuition we go is process both structures until one finishes, attach the remainder directly, and then common in merges, interval problems, and stream processing. Once one side is done, then we need to stop thinking.